Hello everyone. Let's talk about Make. So, as its name suggests, Make is a program that allows us to make things. It does this by providing a mechanism whereby we can provide a list of what are known as rules, which you might think of as tasks that we want Make to perform for us. Okay? So, very often, Make is used for building programs, though it could be used for really any number of things that you would do from the command line. So what I want to do is just demonstrate some of the basic features of Make so that you can use it throughout the semester and you'll understand if we're using it in a project we want you to do and so forth. So here I have a very simple kind of toy project that I put together. It's comprised of several .h and .cpp files. To begin with, I'm going to configure this project to utilize the main.cpp, the person.cpp, person.h, and the testperson.cpp files. So let's go ahead and open main.cpp just to give you an idea of generally what the program does. Now, you'll note that in practicing for this presentation, I'm including dog.h. I'm going to remove that as well as a reference to it down here. Okay, so at this point, this program only utilizes the person class. Quick overview. All this program does is establish some constants and some variables, and then a vector of a vector of pointers to person enters a loop that asks the user to enter a name, creates a person, and pushes the pointer to that person with the name that the user provided onto the people vector that I created up here. Okay. Then at the same time, it also sets the age of that new person or people. And then finally, we just loop through all of the pointers in the vector, printing out the name and age of each person, and then finally deallocate memory. Okay, so it's just a very simple program just meant to demonstrate some of the kinds of things that you may have learned to do in an Intro to Programming course, and it establishes some dependencies. So for instance, we're dependent upon the person class that's being included here. All right, so let me save this, jump back out. So in order to build this program, we're going to need, as mentioned before, several files: person.cpp, main.cpp, person.h, of course, is included, so I don't have to handle it manually when I'm compiling. But these two .cpp files, I do need to include them. So let's just build it, make sure this all works. So again, I need person.cpp and main.cpp to be fed to the compiler. Wake up, compiler. There we go. All right. So then I run the program. Wants a name. So we'll go Fred, Sam, I don't know, Johnny, Sarah, and we'll say Beth. Okay. Now also you may have noticed if you look closely at the code, I just set the age as the number of the particular person that was being added. Okay, so the program runs. Now, this is a pretty simple program to build. It just has those two .cpp files, but it demonstrates the fact that often programs have multiple files that need to be included. The larger the project, generally, the more files are going to need to be included and managed and so forth. And so this can get unwieldy, right? We don't want to have to type G++ and then 1,000 different .cpp files. Also, we could have some kind of structure to the program where we have folders and subfolders and various source files in those. And this can just get out of hand real quick, okay? So one of the things you may have seen people do is kind of a shortcut where they'll say, oh, I just want to compile everything that's a .cpp file into my program. Well, in this case, and in many other cases, that won't work. And the reason it won't is because of this testperson.cpp file that we have right here. So what this file is meant as a placeholder to demonstrate what we might do with our classes. So the person class might well have a file like this created for it that tests the class methods that I use to do unit testing and so forth. So I haven't actually written any tests here. This is just a demonstration. But you could imagine then that I'd have this file that has its own main function, as well as code that then goes through and performs unit tests on the methods for the class, etc. Not out of the ordinary at all. That kind of thing is done a lot. So the issue, though, is that test_person has its own main function. And so if I just try to build, I'll get here, okay, everything, compile everything with .cp extension on the file name, you'll notice the compiler's upset because it says, hey, we've got duplicate main symbols. So this won't work. We have to, in this case, specify the specific .cpp files that we're wanting to build for our purposes. If I'm wanting to test the class, then I'm going to use the test_person.cpp file. If I'm wanting to build the project that actually runs normally, then I'm going to want to use the main.cpp file. And I can't use them both at the same time. Okay, so this demonstrates a situation, kind of a very simple example of a couple of situations where we might want to be able to automate different configurations for our project in terms of how we want to build it, or just different tasks in general. So make is very often included on Unix type systems, especially if you've installed any kind of build packages and so forth, compilers, etc. You can check to see if you have it by simply typing which make, and what which will do is it will loop through the different locations in your path looking for an executable, looking for a program with the name that you then provide, in this case make. And then if it finds one, it'll list the location where it found it. So this is the location where it found make on my system, and so what if I type make and try to run it, it's the program at this location that's going to execute. Okay? Now, as I mentioned earlier, we need to provide make with a set of rules or tasks that we want it to perform. And we'll do this inside of what's known as a make file. Now, typically, by default, we'll actually just name the make file with a capital M. You can use files with different names, but we're not going to get into that for now. We're just going to show the basic behavior. So let's create a make file. And I'm just going to demonstrate first a very simple make file that simply builds our project. Now, as I keep referring to these things called rules. And again, you can think of them as tasks. So I'm going to create a rule simply called, we'll call it project. This isn't going to be a great name. You'll see why in a minute, but it's just to demonstrate the point. So a rule is just given an identifier like this, followed by a colon. And then we can list a set of what are known as dependencies here. I'm not going to do that yet. I'll come right back to it in just a minute. I'm just going to hit enter for now. And then on the next line, I'm going to put the command that I want to be associated with this rule name. But before I put the command, I have to insert a tab. And it must be a tab, okay? Not a series of spaces. It must be a tab. Otherwise, you'll confuse make and it won't work properly. Then we just type the command that we would have typed at the command line. So g++ person.h main, excuse me, not person.h, person.cpp main.cpp, and I'm going to save that and exit. So now you can see that I have my make file in the directory. Okay, so if I just type make and I try to run it with no command line input, then it will by default look for a file called makefile with a capital M, and it will automatically look for the first rule in that file and try to execute it. Oops, so we'll just do that now. Now here you can see that it executed the command that I had given it for the rule. So for instance, I'm going to go ahead and delete a.out. You can see that there is no a.out, and now if I run make, it runs that command, and now there is a.out, and we can run it. Okay, now I don't have any interest in running the program right now, so I'm going to use Control-C to stop it. There you go. So that's a very simple make file. Now I mentioned before that the name that I gave to that first rule wasn't really a great name. And the reason is because it's not taking advantage of a couple of things we'd want to do with our rules. For one thing, we want our rules to kind of reflect what the command associated with them is going to build, what it's going to do. For another, if we do that and there's a tight association between the name of the rule and the things that it creates, then there's some really neat benefits we can get from make. So I'm going to rename this rule list person. And the reason I'm calling it that is because I've also decided that I'm going to name the output that's generated list person. So the executable generated by this command will now be called list person. So let's go ahead and create that. All right, so now if I run make, you'll notice it ran that rule again, and I now have this program list person that's been created. So now check this out. If I run make again, it says list person is up to date. So it didn't actually execute the rule, and the reason it didn't is because it looked at the rule name and then checked to see if there was a file called list person that already existed, and it did. So then what it did is it looked at the modification date on list person and compared that to the modification date of its dependencies. Now in this case, there are no dependencies, okay? And so it simply said, hey, has anything that this program, or excuse me, this thing that I'm creating, more appropriately here, has anything it depends on changed since the last time it was built? And of course I don't have anything listed at all, so the answer is always going to be no. So this rule, the way that it's set up, it builds our executable, but then it's never going to run again because it says, hey, I'm always up to date. Now that seems like a problem, but this is actually kind of what we want. We just need to finish the process. I keep referring to dependencies. Well, dependencies are the things that the rule needs to execute. And so in this case, in order for this command to do its thing, it's dependent upon person.cpp, main.cpp, and actually I'm going to reorder this, person.cpp and person.h, as well as main.cpp. So now when I try to run this command, it's going to compare the modification date or the timestamp that indicates when list person was last changed, and compare that to the timestamps on each of these three files. If any of these files has been changed after the last time that this rule was executed, based on the timestamp associated with the file list person, then it'll execute the rule. Otherwise, it'll say, hey, it's up to date. Let me demonstrate what I mean. So again, nothing has been changed on any of those source files. So if I type make, it says it's up to date. So now I'm going to run touch on the main.cpp file. That simulates making a change to the file. And now you'll notice if I run make, it executes the rule. This is because it says, oh, you changed main.cpp, and so since this rule is dependent on main.cpp, I need to run it again to make sure that list person is up to date. Okay, now again, we're just simulating what might happen if someone came in and made a change to the file where they said, all right, well, instead of 5, I'm going to do 3 here. And so you see if I run make, there, it rebuilt the project. If I run it again, it says, hey, it's up to date. There haven't been any changes since the last time I tried to execute that rule. Okay, now, this is all fine and good, and it's simplified this one task I want to perform, but the real power of make comes in the fact that it lets us automate many tasks by creating multiple rules. So I'm going to add another one here. One of the things you've seen me doing is removing, well, I'm going to remove a.out. We're not even calling it the executable that anymore, but you've seen me need to remove list person. Okay, so there might be, just in general, reasons we want to clean out the directory of things we've been building. So I'm going to add a rule called clean, which is a very common thing to do. And clean is just going to remove, in this case, list person. And we'll add to this as we add more rules and build more things in a minute here. But for now, it's just going to to delete the file list person if it exists. Okay, so now if I run make, I want to run the clean rule instead of the list person rule. How do I do that? Well, by default, it will execute the first rule in the file unless I provide a specific rule name that I want to execute. So if I say make clean, it will look for a rule called clean and run it. So there we go. We've now used that rule to clean up our folder here a little bit. Again, very trivial rule at this point, but you're going to see that that make clean rule is going to be more useful in a minute because we're going to actually build more stuff. Now, this is all fine and good, and this demonstrates some of the potential for a make file. But notice we still have a little bit of a problem. Let's say that my program doesn't consist simply of a couple of these .cpp files, but actually dozens or hundreds or thousands, right? At this point, because of the way that my make file is arranged, if I change any of the source files that this one command is dependent upon, then the whole thing has to be rebuilt, meaning that all of the .cpp files have to be recompiled. Now, we talked about the fact that we can compile in stages and we can interrupt the process. And that's going to be really useful because also, as you'll recall, the first stages of compilation where we're going from C++ code, for instance, into assembly code and then assembly to object code, those take longer than going from a bunch of object code into an executable, in the sense that it simply takes longer to do the compile phase than it does the linking phase. It's more complicated. And one of the things that we can do and that makes easier for us is what's known as partial compilation, right? Where we can compile just pieces, or I should say modular compilation, where we can compile pieces of a program and then tie those pieces together. And what that allows us to do then is to target changes and only recompile the files that need to be recompiled. Let me demonstrate. So right now, if I make a change to any of these files, person.cpp, main.cpp, or person.h, then all of them will be recompiled by this command. I'm going to add another rule that I will call person.o, and it will be dependent on person.cpp and person.h, and I will use it to build a person.o file, or the object code for the person class, by using the -c flag, which tells it to stop after it's tells the compiler to stop after it's generated the object code, and then simply person.cpp will be the input. Now I'm going to change this first rule to be dependent on person.o and main.cpp, and we'll include person.o here. Now, forgot my H there. There we go. Now, let's talk about what this is going to do. So if I try to run the list person rule, it's going to check to see, hey, is there something called person.o? If person.o does not exist, it's going to look to see if there's a rule it can use to build it. In this case, there is. It will then check to see if the necessary dependencies exist, person.cpp and person.h, and then it'll execute the rule. Now, just like with list person, let's say person.o is already executed at some time in the past. Then in that case, there'll already be a person.o file. And so just as with list person, it will then check to see, okay, what's the modification timestamp on person.o? And is that newer than the modification timestamp on any of the dependencies? If that's the case, then it's already up to date and I don't need to build it. On the other hand, if there's an indication that there have been changes made to person.h or person.cpp after the last time this rule executed, then it'll execute it. Okay, now recall that all happened when list person checked for person.o. So we have now kind of a chain or a nesting of dependencies happening here. List person is dependent on person.o, which is dependent upon these things. So if person.cpp or person.h have changed, then person.o will be rebuilt and then used to build this rule. The cool thing is that if person.o doesn't need to be rebuilt, then it won't be. So we won't waste any time on compilation of those files, and we'll simply use the person.o file right here in this rule to complete our task. So let's demonstrate that. So I'll save this, and I'm going to run make clean real quick. This is a habit. Now you'll notice it gave me an error in this case because there was no list person, but I couldn't remember when the last time I ran it was. So I just went ahead and ran make clean, doesn't hurt anything. And now when I type make, you'll notice two rules got executed. First, the rule that built person.o, and then once that was done, the final rule executed. Now if I run make again, it says, hey, everything's up to date, nothing changed. Now check this out. If I touch to change the timestamp on main.cpp, so I'm simulating that I made changes to my main.cpp file, and I run make again, notice that it ran the rule to build list person, but it didn't recompile person.cpp as we had to do up here. Didn't need to because no changes had been made to it. So this can save a ton of time, right? Because now because of the way I've set up my project in Make, it's only building or only compiling, excuse me, the files that need to be compiled. So if this was a program consisting of thousands of files, I've just possibly cut my compile that time down from minutes or hours, maybe even days, to a really short period of time, the time it took to link, which in this case was a small moment. So let's build on this idea just to again demonstrate the flexibility. Now I will point out, if I had changed, let's say I changed the person class and I modified person.h file, if I try to build it, now it does need to rebuild person.o, and so it did so. Let's extend this notion. Let's go in here and change our make file to also include a rule for building the dog class. Now, oops, sorry, that will be dependent on dog.h and dog.cpp. And we'll do the same thing. Okay, and I'm also going to change main.cpp to actually utilize that class. And all I'm going to do is just really trivially create one of those objects. Okay, oops, there's something I forgot. So you may have caught it. Though I added a rule for building dog.o, I also need to add that now as a dependency for my list person and add it to the rule. Excuse me. I need to add it as a dependency to the rule and add it to the command. All right. So now if I type make, oh, well, interestingly, you have to spell things properly for make to work. Go figure. Okay, so let's fix that. Where did I say dago? There we go. That should be dog. There we go. All right. So now if I run make, what have I done wrong here? No matching constructor for initialization of dog. A dog. Let me look real quickly at my .h file, see what we've got. Okay, so I'm supposed to provide a name when I try to create dog. So I need to modify my main.cpp file so that when I create a dog, we give it a name. My apologies. Now at least you know that it's real, right? It actually is trying to build something. Okay, let's run make again. There we go. So now builds the program. Again, I'll demonstrate that it does indeed execute. I don't want to waste my time running it, but you get the idea. So let's test it now. So the idea would be that once again, It doesn't build anything if nothing's changed. It says, hey, it's already up to date. You can just use it. And now if I touch, say I made changes to the dog.cpp file, you'll notice that now it rebuilds the dog class, the dog.o file, I should say, and then executes that rule that's needed to build this person. Okay, so I have a lot of control over what's going to happen here. All right, now, one problem we've created for ourselves with all these rules, though, is that we're creating lots of intermediate files like person.o and dog.o and so forth. Now, not a big deal. It's part of the project and it's helping to speed us up. But you remember I created that clean rule, which was intended for cleaning out the directory of all of the things that I did when I was building. And so now, in addition to the list person executable that's being created, we've also got these .o files that are being created. So maybe I want to improve my clean rule by adding this to my command, star.o, oops, not 0, star.o, adding this modification so that all of the object files will be deleted when I clean as well. So if I hit Control O and I exit, now if I say make clean, cleans things up for me nicely. Okay, got rid of all those object files. Sometimes we'll want to do that because maybe we want to force everything to be rebuilt. Okay, now I've done that. If I run make now, all the rules have to be executed, which you see just happened. Okay, one last thing that I'd like to talk to you about before I wrap this up, and that is variables. So we can actually use variables to make modifying and keeping track of our make files easier. Let's go into our make file, and I'll demonstrate what I'm talking about. So you'll notice here, I'm using the G++ compiler to build my project. So just as a demonstration of how we might use make variables, it's possible that for some reason I may want to change the compiler from time to time. Maybe I upgrade it, switch to a totally different vendor, who knows. So it's actually a pretty common thing to use a variable to represent the compiler, so I can just change it in one place. So make variables are not exactly the same as variables we use in programming languages like C and C++. The syntax is a bit different, but they do serve a similar purpose. So I'll just give an example. So I'm gonna create a variable called cxx. Okay, and that's just I'm going to use that as the name of my compiler throughout my make file. And I'm going to, for now, set that equal to G++, because that's what I've been using. So now what I'd like to do is reference this variable in my rules. So instead of saying G++ directly, I'll want to get the contents of the cxx variable. And that's the syntax we'll use for that. So this syntax, where we've got the $sign and then the parens with the variable inside it, that will expand whatever's inside the variable and place it there in the rule. Okay, so I'm going to go ahead and I've only modified one so far, so you notice these are saying G++. I'm going to run make clean and then I'll run make again, and what we should see is that G++ is executed 3 times just as before. It'll look the same, but it will be pulling that value or that string from this variable. So let's go ahead and demonstrate that. So say make clean and make, and sure enough, looks just like it did before. Okay, so I'll go in now and duplicate that change for each of the other rules. Verify everything works as before, and there you go. Now again, what's useful about this? Well, you could have dozens or hundreds of rules, and if you did decide to change the compiler, you'd be in a world of hurt. You'd have to go through and change all of those. But now we could just change it right here. The compiler is not the only thing we might want to keep track of. So there might be a set of flags, build flags, that we want to use in every case. So for instance, maybe I always want to turn on all warnings. Okay, and maybe I have a list of other flags that I'm using and so forth. Well, now I could simply add this variable to my command, and now those flags are going to be inserted. And if I want to make changes, like no, I don't want to have all those warnings on, then I can just make the modification up here, and the effect shows up everywhere that that particular variable is being used. Okay, so again, now you can see that because I turned on warnings and used that variable in the rule, I'm now getting a warning about an unused variable in my code. Okay, so that's all for now. Hopefully this gives you enough of a foundation that you want to start experimenting a bit with Make, and if you encounter it, you have the basics, so it shouldn't totally overwhelm you. You should be able to kind of work through what's happening there and do what you need to do. Until next time, have a great day. Thanks.